Okay, welcome back to Information Systems Resource Management 5.2. We're going to talk about the 7 types of distributed systems. So the first type is a host-based hierarchy. And before I begin, we're going to go through the 7 fairly quickly on this module. There isn't that much that's really absolutely necessary. This is just kind of to give you a taste of the types of distributed systems there are. Some will be more familiar than others. For most end users, they won't really care. It doesn't matter. But if you're an IT manager, or even if you're a functional manager who's working with IT, it sometimes helps to know how these systems are going to be distributed so that you can understand the risks and the costs associated with maintaining these applications. So again, the host-based hierarchy is a central controlling mainframe or mini computer with some PCs or dumb terminals at the bottom. So here we have the master-slave type of arrangement whereby the mainframe is doing all the processing and it sends all the information down to the client. It's a very simple, straightforward process, and it's very similar to what you see with, like I mentioned earlier, in the previous module, of a web browser that basically makes a connection to an application server or a web server for processing. Where is the data stored? It's stored behind the application server. It could be in a database, it could be in the mainframe, there's separate storage and so forth, but it's still a host-based hierarchy that some extended computer is doing the processing on our behalf, and all we're doing is benefiting from the result either on the screen or through another device. Decentralized standalone systems, well, decentralized does not really form a distributed system, but this is again a holdover. You see some ERP systems where you might see this in a subsidiary where an individual subsystem of order entry or operational or logistics system just sits around and all these dumb terminals are connected to it. And then there's another one in another area that's completely separate. Don't see this that much. I haven't seen this in years in any particular place except for 1 or 2 locations where the system is so unique that it's never been reasonable to either build a new system or actually no one's actually built one for that organization. Peer-to-peer LAN-based systems, these are basically your file servers. We pretty much know, we've seen some of these. You have a file server somewhere or print server or even an intranet location, and the individual computers can connect to other computers and they can share information between them. So interconnecting LANs rather than any hierarchical communication through a central hub. There is no superior computer. They're just all computers on a network that each computer can access. In the hybrid, which is what you'll see in a lot of places, you'll see these peer-to-peer type of networks like a Windows workgroup network, or connecting to a mainframe, something connecting to a mainframe, or connecting to another file server, and we just mix and match all these. You can also allow external links to companies to extend the network, or doing it to subsidiaries, and this cooperation allows companies to take advantage of specialized computer programs. So for example, if an external partner doesn't have, say, an HR system for whatever reason, they could actually connect in and leverage the HR system that company A has because there's such a close partnership or there's a relationship between the two. You might not see that in terms of HR, but you might see that in terms of ordering systems like inventory systems, especially when you get into distribution channels or drop ship. What some companies do, like a retailer who is actually a drop shipper or connects to a drop shipper, the inventory is managed by the drop shipper itself. So it's a service that they've provided, and then they actually have additional inventory systems that will do the ordering. This process of pulling together such individual components is known as systems integration. Now, we're going to broaden this a little bit because systems integration means taking any one of the systems, an individual application that does the processing, and integrating it with something else. And this could be in the form of data or direct integration, say via web services. In client-server systems, basically we ended up now having a single server on the network with some host PCs, and what they did was they distributed the load between the client and the server. So certain things would be done on the server, certain things would be done on the client. A little bit more detailed, what we could say is it allowed us to create what was known as a thick client. The thick client is basically where you get this very rich application that will do more of the work before it gets to the server. An example of this would be if you have an application on your computer and you start typing in, let's say, the first 3 letters, and as you type in the first 3 letters, it knows who you're talking about without going back to the server. Or it may do a validation of, say, the telephone number or the email address without actually going back to the server. The processing is done on the PC as opposed to going back to the server. Web-based systems are really thin clients. They're actually, these internet clients that basically send the information back. In some cases, they've overloaded JavaScript on the browser, so it's doing a little bit more work. It's making it a little bit thicker, if you will, than the original thin client. Somewhere in between, to give you two different additional technologies that might be familiar to you, one is called Silverlight by Microsoft and the other is Adobe Flex. And what those try and do is those try and create an even richer experience somewhere between the thin client and the pure thick client that will allow you to do more graphical capabilities. I can take a chart and I can start moving things up and down so that I can change different levels and see what the results might be. If you're interested, you can go to adobe.com and look at Flex and see some examples of what they've got there. And so this chart here of client-server computing kind of shows you the hierarchy where things are through the network, and there are different ways to actually set this up. Internet-based computing is a form of the thin clients that we were talking before. Most of this distributed model, it includes the internet, so we're going to communicate via the internet, and the processing is done as what we call in the cloud. There was a concept known as network computers, but that didn't take off at all. But now with mobile tablets, with tablets and mobile phones and so forth, it's kind of there. You have computers or these tablets whose sole purpose is really to connect onto the internet, even though you can do a little bit more processing. But now we're swinging a little bit back as these applications or these apps on the phones and the mobile tablets are increasing. So that it's this cycle where we want to push things back to the server, away from the client, and pull things back to, and then ultimately pull them back to the client because we're not happy with or satisfied with performance. So thin clients are logical for handheld, but increasingly popular for the desktop in terms of the browsers that we had, and in terms of other types of, like Chrome is a very thin type of browser. Where this is beneficial is updating new versions of the software only have to occur on the server. They don't have to really occur on the PC or even on the mobile device. Authorized software, we know that the software that's on the server is authorized. There's no copies because we only need one single one. And we can then control everything that's done because everything that's processed because it's done on the server. So it gives us a lot of security, a lot of flexibility in terms of making sure that the clients have it when they need it. So there's a lot of benefits to this type of distributed system. And finally, the web services here allows applications to integrate with other applications via the internet using these web services. And you can take a look at Google a web service, what's called WSDL, or Web Services Definition Language, or SOAP, S-O-A-P, Small Object Access Protocol. And what will happen there is that you'll see what the format looks like. All it's doing is an application says, I need some information from another system. And so it generates this request, sends it over the internet, and then the response comes back in a similar predefined format, but they're all generally the same. It's an XML-based structure that can easily be parsed and then processed by the calling application. So what web services actually do is they will encapsulate functionality from an existing application in an XML envelope. What we're saying here is that when I say the function, we're talking about validate postal code. So what will happen is we want to validate a postal code. We will create this XML document. The XML document will basically say validate, and then it'll have a data field. We're going to validate, let's say, the zip code 11111. What it will then do is it will send that information to the server. The server will then take that apart from its envelope, find the function that it's supposed to call, and then find the data piece as an input, get an output, and then pull it back and send it out in the same way, creating an XML with here's your response and here's the data. And the key here is that you expose these services to others, either internally or externally. I can expose my point of sale system to a third-party vendor who's acting as a reseller for some of my items. So the web services standards, the three software standards are XML, WSDL, and UDDI. Universal Discovery, Description, and Integration was the only one I didn't mention of the three. And the communication standards are the Simple Object Access Protocol, HTTP, obviously, which is the Hypertext Transfer Protocol, and TCP/IP, and it's basically a stack from there. So that concludes this piece. I'll see you for the next piece.